National Electrical Code Article 230.71 addresses the number of service disconnecting means allowed for each set of service entrance conductors. The code specifies a maximum of 6 service disconnecting means for each service. This regulation applies to situations where multiple service feeders are permitted. Therefore, if 2 separate service feeders are installed, each feeder is allowed up to 6 service disconnecting means. The rationale behind this rule is to ensure that in the event of an emergency or for maintenance purposes, the entire electrical service can be readily disconnected with a limited number of actions. In the context of a scenario with 2 service feeders, each applying a main lug only or a mellow switchboard, the rule remains consistent. If one feeder is rated at 3000 amps and the other at 2000 amps, and each switchboard currently has 3 disconnects, adding one additional disconnect to one of the switchboards is permissible, as long as the total number of disconnects for that specific feeder does not exceed 6. It's important to note that the location of these switchboards is also a factor. If the switchboards are located in the same electrical room and feed circuits within a common building, the service disconnecting means for each set of service entrance conductors are considered to be at the same location, which is generally in compliance with code requirements. However, it is crucial to consider the specific requirements outlined in National Electrical Code Article 230 to ensure adherence to all applicable regulations. Firstly, the service disconnecting means must be suitable for the available fault current at their terminals. This requires performing a fault current study to determine the maximum potential fault current at the service equipment. The disconnects must have an interrupting rating equal to or greater than the calculated fault current. Secondly, the disconnects must be readily accessible. This means they must be located so that they can be easily reached without requiring tools or climbing over obstacles. The intent is to allow for quick and easy disconnection of the service in case of an emergency. Thirdly, the disconnects must be grouped together. This requirement aims to consolidate the disconnecting means in one location for ease of operation and maintenance. If the disconnects are located in separate rooms or areas, it can create confusion and increase the time required to de-energize the service. Fourthly, each service disconnecting means must be legibly marked to indicate its purpose. This helps identify which loads are being served by each disconnect and prevents accidental disconnection of critical circuits. The marking should be durable and easily visible. Fifthly, the service disconnecting means must be capable of being locked in the open position. This is a safety measure to prevent unauthorized re-energization of the service during maintenance or repair work. The locking mechanism should be robust and tamper-resistant. Sixthly, the service disconnecting means must be manually operable. This means they must be capable of being operated by hand without the need for special tools or equipment. This ensures that the service can be disconnected even in the event of a power outage or equipment failure. Additionally, the code stipulates that the service disconnecting means must be located at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. This requirement ensures that the service can be quickly and easily disconnected in case of an emergency such as a fire or flood. The disconnecting means must be suitable for the conditions such as being rated for outdoor use if located outside and must be clearly marked to indicate their purpose. Furthermore, it is important to consider any local amendments or regulations that may modify or supplement the requirements outlined in the National Electrical Code. Local jurisdictions often have their own specific rules and interpretations that must be followed. Consulting with a qualified electrical inspector or engineer is always recommended to ensure full compliance with all applicable codes and regulations. It is also important to ensure that all electrical work is performed by licensed and qualified electricians who are familiar with the National Electrical Code and local requirements. Improperly installed or maintained electrical systems can pose serious safety hazards and may result in property damage, injury, or even death. Therefore, it is crucial to prioritize safety and ensure that all electrical work is performed in accordance with industry best practices. In summary, the National Electrical Code permits up to 6 service disconnecting means for each service entrance conductor. When multiple service feeders are installed, each feeder is allowed up to 6 disconnects. The disconnects must be suitable for the available fault current, readily accessible, grouped together, legibly marked, capable of being locked in the open position, and manually operable. Compliance with all applicable codes and regulations is essential to ensure the safety and reliability of the electrical system. When evaluating a situation involving multiple service feeders and disconnects, several key factors must be carefully considered to ensure compliance with the National Electrical Code and to maintain a safe and reliable electrical system. Firstly, the available fault current at the service equipment must be accurately determined. This requires performing a detailed fault current study that takes into account the utility source impedance, transformer impedance, conductor impedance, and other relevant factors. The service disconnects must have an interrupting rating that is equal to or greater than the calculated fault current. Installing disconnects with an inadequate interrupting rating can result in equipment failure, arc flash hazards, and potential injury or death. Secondly, the coordination of overcurrent protection devices must be carefully evaluated. The service disconnects, along with any downstream fuses or circuit breakers, must be coordinated to ensure that the overcurrent protection device closest to the fault opens first, minimizing the extent of the outage and preventing unnecessary damage to equipment. Time current curves should be reviewed to verify proper coordination. Thirdly, the accessibility and grouping of the service disconnects must be carefully considered. The disconnects must be readily accessible to authorized personnel and must be grouped together in a common location. This allows for quick and easy disconnection of the service in case of an emergency or for maintenance purposes. The disconnects should be clearly labeled to indicate the loads they serve. Fourthly, the ampacity of the service entrance conductors and the service disconnects must be properly sized. The conductors and disconnects must be rated to carry the calculated load current plus any applicable demand factors. Undersized conductors or disconnects can overheat and fail, leading to service interruptions and potential fire hazards. Fifthly, the grounding and bonding of the service equipment must be properly installed and maintained. A properly grounded and bonded system provides a lower impedance path for fault current, helping to minimize voltage rise and reduce the risk of electric shock. The grounding electrode system must comply with the requirements of National Electrical Code Article 250. Sixthly, the service equipment must be protected from physical damage. The disconnects and other service equipment should be located in a secure area and protected from impact, moisture, and other environmental hazards. Enclosures should be properly sealed to prevent the entry of water and dust. Seventhly, the service equipment must be properly maintained. Regular inspections and maintenance should be performed to identify and correct any potential problems before they lead to service interruptions or safety hazards. The disconnects should be tested periodically to ensure that they operate properly. Eighthly, the relevant sections of the National Electrical Code should be carefully reviewed and understood. The NEC is a complex document, and it is essential to have a thorough understanding of the applicable requirements. Consulting with a qualified electrical inspector or engineer can help to ensure compliance with the code. Ninthly, local amendments and regulations should be considered. Local jurisdictions may have their own specific requirements that supplement or modify the NEC. It is important to be aware of these local requirements and to ensure that the installation complies with all applicable codes and regulations. Tenthly, proper documentation should be maintained. Complete and accurate documentation of the service equipment, including drawings, specifications, and test reports, should be maintained for future reference. This documentation can be helpful in troubleshooting problems and in planning for future upgrades or modifications. In addition to these factors, it is also important to consider the overall design and layout of the electrical system. The service equipment should be located in a convenient and accessible location, and the wiring should be installed in a neat and orderly manner. The system should be designed to minimize the risk of electrical hazards and to provide a reliable source of power for the building or facility. By carefully considering all of these factors, it is possible to design and install a safe and reliable electrical system that complies with all applicable codes and regulations. Remember that electrical work can be dangerous, and it is always best to consult with a qualified professional if you have any questions or concerns. The safe and reliable operation of an electrical system depends on a combination of factors, including proper design, installation, maintenance, and adherence to applicable codes and standards. Regular inspections and testing are essential for identifying potential problems and ensuring that the system is operating safely and efficiently. Some common electrical problems that can lead to safety hazards include overloaded circuits, loose connections, damaged wiring, and faulty equipment. Overloaded circuits can cause overheating and potentially lead to fires. Loose connections can create resistance and generate heat, which can also lead to fires. Damaged wiring can expose live conductors and create a risk of electric shock. Faulty equipment can malfunction and cause a variety of problems, including power outages, equipment damage, and safety hazards. To prevent these problems, it is important to have a qualified electrician inspect the electrical system on a regular basis. The electrician can identify any potential problems and make recommendations for repairs or upgrades. Regular testing of the electrical system is also important. Testing can help to identify problems that may not be visible during a visual inspection. Some common electrical tests include insulation resistance testing, ground impedance testing, and circuit breaker testing. Insulation resistance testing measures the resistance of the insulation on electrical conductors. Low insulation resistance can indicate damaged insulation, which can create a risk of electric shock. Ground impedance testing measures the impedance of the grounding system. High ground impedance can reduce the effectiveness of the grounding system and increase the risk of electric shock. Circuit breaker testing verifies that the circuit breakers are operating properly and will trip in the event of an overcurrent. In addition to regular inspections and testing, it is also important to follow some basic electrical safety precautions. Never overload circuits by plugging too many appliances into a single outlet. Use extension cords sparingly and never run them under rugs or furniture. Replace damaged wiring or equipment immediately. Avoid working on electrical equipment while it is energized. If you must work on energized equipment, use proper personal protective equipment such as insulated gloves and eye protection. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous, and it is always best to leave it to the professionals. By following these simple safety precautions, you can help to prevent electrical accidents and ensure the safety of yourself and others. It is also important to be aware of the potential hazards of arc flash. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash hazards, it is important to follow proper safety procedures and to use appropriate personal protective equipment. Some common arc flash safety procedures include energizing equipment before working on it, using insulated tools, and wearing arc-rated clothing. Arc-rated clothing is designed to protect against the heat and flames of an arc flash. It is important to choose arc-rated clothing that is appropriate for the level of hazard present. The level of hazard is determined by the available fault current and the clearing time of the overcurrent protection device. Arc flash studies can be performed to determine the level of hazard and to identify the appropriate personal protective equipment. In addition to following proper safety procedures and using appropriate personal protective equipment, it is also important to have a written safety program. A written safety program should outline the procedures for working on electrical equipment and should identify the potential hazards of arc flash. The safety program should be reviewed and updated on a regular basis. Employees should be trained on the safety program and should be required to follow the procedures outlined in the program. By taking these steps, you can help to protect against arc flash hazards and ensure the safety of your employees. The National Fire Protection Association, or NFPA, has developed a standard called NFPA 70 that provides guidance on electrical safety in the workplace. NFPA 70E covers a wide range of topics, including arc flash safety, shock hazards, and lockout/tagout procedures. The standard is updated on a regular basis to reflect the latest advances in electrical safety technology. It is important to be familiar with NFPA 70 and to follow the recommendations outlined in the standard. Compliance with NFPA 70E can help to reduce the risk of electrical accidents and injuries in the workplace. In summary, electrical safety is a critical concern that must be addressed in all workplaces. By following proper safety procedures, using appropriate personal protective equipment, and complying with applicable codes and standards, you can help to create a safe and healthy work environment for yourself and others.